versus RPM ignition table. Now this is based on TPS as well, alpha N, just like we have in our main fuel table. So we need to go in here and configure things specific to what we're doing in here. So we can see we have our throttle position here, engine speed. Let's click on our edit axes. Let's first work on the engine speed. And we know we're revving the engine out to 9,000 RPM. Let's go here to generate, and let's go here 0 RPM and go up to 9,000. That's the peak RPM I plan on spinning the engine to. The increment here will move in 500 RPM increments, and click OK. Now the next thing is our row axes. This is something we need to consider. So our throttle position is what we have in our row axes here. I'm going to go into a custom option here, and we're going to just generate this custom. We're going to start off at 0, close throttle. Then we'll do 1, then we'll do 3, and then we'll do 5. Let's do 7, and we'll probably try 9, 12, 15, get specific with this, 20, 40, 60, 80, and then 100. And we'll see the ignition timing isn't going to vary as much as our fueling in terms of throttle angle, but I want to have a decent resolution in here. So looking at this, this table looks a little bit chaotic. What we're going to do first, let's just grab all the values in the table and let's set them to 0. Now, let's talk about what we need in terms of ignition timing and how this is going to work. Now, I'm going to say at idle, 0 to, let's say, 1,000 RPM, and let's say from 1 to, 3% throttle, even 1,500 RPM right here. So 0 to 1,500 RPM, 0 to 3% throttle. I'm going to set these values at something like 20 degrees. Now we're going to have our spark timing feedback controlling our idle spark. This is going to be what it reverts to after we drive off idle. Now, I'm going to say here, generally, 3,000 RPM and above, and probably about 20% throttle. I'm going to set these values at roughly 30 degrees. This is a reasonable starting value for spark timing for pretty much any engine, but this engine's high compression, and below, let's say, 20% throttle angle, we're at relatively light throttle, so we can run at least 30 degrees of timing. Now here at, let's say, 1,500 RPM to 0 at 20% throttle, I might put this at something like 5 degrees. And then we'll ramp it between that, we'll do V, and we're going to horizontally interpolate between 15 and 3,000 and do H. We'll go between these two and do H. Now, when I'm at full throttle here, 80 to 100%, that's essentially full throttle. I'm going to say at 3,000 RPM, I want to put a conservative value, something I can start off with so I can dial my fueling in and not have to worry about knock or pre-ignition. And that's the goal here, even in part throttle cruise here, below 20% throttle. We want to put values that are too aggressive. 30 to 40 degrees is pretty normal for most inline 4 and 6 cylinder engines in light throttle conditions, light throttle cruising. So we want to be a little bit conservative with that. That's why I put 30 degrees. It gives us good spark timing to have some decent torque output out of the engine. We're probably not going to be reaching maximum brake torque with 30 degrees, but we'll be close, but it'll be reasonable so I can drive my engine. Now at full throttle, I don't want to go crazy and have a bunch of timing into it. So again, I avoid knock or pre-ignition. I'm going to go ahead and set it to something like 14 degrees. That's pretty reasonable. I'd expect full throttle with 12.5 to 1 compression on pump gas. I'm going to be anywhere between 20 to maybe 26 degrees on this particular engine. So I'm going to go about 8 to 10 degrees less than that range and put that into full throttle. Now, between 80 and 20, I'll go between these two and click V, vertically interpolate. So we're going to go ahead, as our throttle angle increases, our manifold pressure and load's increasing, airflow's increasing, the engine cylinder pressure is increasing. We're going to go ahead and decrease that spark timing. Now, when I'm talking 160% throttle, let's say 0 to 1,000 RPM, we're going to leave that at 0 RPM. Or 0 degrees timing, not RPM. And then we're going to go between here and we're going to do V, just vertically interpolate, and do the same thing here. We're going to do H, and then do a V right here. So we're just doing some blending in the table. So now we have something in here that's a respectable starting point for spark timing. That's conservative. The engine will make some kind of power output, but it allows us to focus on doing our fuel tuning first, then come back into our spark timing. It's always the order of operations that we want to move in, tuning any engine. So let's go ahead.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.